Okay, okay guys, let's look at range. Okay, the projectile motion. Now, like I said in my previous videos, once the body is projected vertically downward, this velocity is maximum at the point of projection. It decreases progressively and becomes zero at maximum height. Then that's the reason it returns. If the velocity does not decrease and becomes zero at a point, the body will continue moving vertically upward. It's because it becomes maximum from the point of projection, decreases and becomes zero, it comes down. However, at every point, let's assume that the ball is at this point. There are two components of the velocity. There is vertical component of the velocity and the horizontal component of the velocity. At this point is the resultant velocity u, which is velocity with which the body is projected. Now, what I mean is you have this is the velocity, which is vertical component, uy is the horizontal component ux. Okay, this is angle, okay, of projection. Now uy is u sine theta, ux is u cosine theta. Now, because the Earth's gravitational field intensity, F over m, which is g, does not act horizontally, so the horizontal component of the velocity remains the same throughout the flight. What changes is the vertical component because it is being acted upon by the Earth's gravitational field intensity, otherwise known as the acceleration rate of gravity. Now, if you look at that, because nothing, the gravity doesn't affect the horizontal component, the range r is simply velocity times time. See that? So velocity times time of flight. Okay, we derived the time of flight from our previous videos. What it means is, of course, if everybody is projected vertically upward, time of flight, drive time, u is going up, uy is u sine theta. Okay, then v is 0 at this maximum height before it returns. We're calculating time of flight. We've derived it before, but for the benefit of those who are just watching this one, let me repeat it. U is 0 because it has to be 0 so that it can return. Now g is negative because it's going against the Earth's gravitational field. So t is what we're looking for. So of the 4 parameters of motion, volts. So what is done here is S. So the equation of motion that doesn't have, let's call this one, that doesn't have S is V equals to U plus AT. Okay, so V is 0, so U is the vertical component of the velocity, which is U sine theta. G is negative T, so T becomes U sine theta all over G. Now, it takes equal time to move from this point to this point and back to this level of projection. So time of flight T will be 2T, which is 2 times U sine theta over G. Now, this range is a horizontal motion, which has ux. So if we substitute equations 2 and 3 in 1, we have range r equals v, which is the horizontal component u cosine theta multiplied by t, 2u sine theta over g. That gives us u squared cosine theta, 2 is here, 2u squared cosine theta sine theta all over g. Okay, we can write out as u squared 2 cosine theta sine theta over g. Okay, however, in one of the trig identities, if you have, of course, recall that sine A plus B, the same thing as sine A cos B plus cosine A sine B. So this if we have 2 theta, that is, if A and B are equal, we have sine t theta will give us sine A sine theta cosine theta plus cosine theta sine theta, which gives us 2 sine theta cosine theta. You see? So this is something else. Under color, this is something as this. So we replace 2 cosine theta sine theta with sine theta. So R becomes u squared sine theta over g. This is the range of lines. Thank you very much.